Okay, I'm going to look at this PIMCO page for a moment just to get some context for what interest rates swaps represent. Largely speaking, interest rate swaps are a way of trading interest rate risk. We could take the definition here. An interest rate swap is an agreement between two parties to exchange one stream of interest rate payments for another over a set period of time. Swaps are derivative contracts and trade over the counter predominantly, but also swap contracts also can be traded on exchanges. And we'll have a look at this glossary terms in a moment as well, but a good starting point here is to look at a diagram. And basically, a swap is precisely what it says it is. It's where two counterparties agree to pay each other over a given term, maybe 5 years, maybe 10 years, maybe shorter, a fixed rate of interest, perhaps for a floating rate. And floating rates, the biggest, typically the most significant reference rate for interest rates, for variable interest rates, is LIBOR, the London Interbank Offer Rate. And that LIBOR rate has been through a number of controversies in recent years, particularly because of trader manipulation of that rate. Even though those controversies exist, LIBOR is still overwhelmingly the most significant reference rate for swaps and for many other things, including mortgages and for student loans and for credit cards. Very often you'll see in the small print of financial contracts that the rate payable on a loan or a credit line is linked to LIBOR, so it could be LIBOR rate plus a spread. So LIBOR rate is important, and it's also important in terms of the swaps market. I'm going to have a look also at some notes provided by Chauncey Hull. Chauncey Hull has, we might just take a look at his book for a second, Option Futures Hedge Derivatives. In that book, there is a whole chapter devoted to swaps and additional chapters as well in terms of credit default swaps. And to my mind, the best kind of introductory, comprehensive type treatment of the area you'll get from this book. So it's one that I advise either get it from your library or go online and purchase. Okay, so let's take an example then of what a swap might look like and just tease out some of the issues. Perhaps before I break it down into its component parts, I might just give one more little diagram here. So a plain vanilla swap contract might take the following form. You could have an agreement here to pay 6-month LIBOR and receive a fixed rate. We saw that from the previous diagram we had looked at. The purpose of the swap could be to hedge interest rates, either interest rates going up or interest rates falling, or even just to transform a floating rate liability to a fixed rate liability, or a floating rate asset to a fixed rate asset, or vice versa. It also, in the examples we'll provide later, the swap contract will be seen as a way to broker better, more efficient outcomes. So we look at issues around comparative advantage and absolute advantage in terms of rates that different borrowers might face, and if they use a swap they may be able to negotiate a more competitive rate. And in that sense the swaps market helps to make markets more efficient, and that's also kind of a strand in the literature, that when academics look to find a derivative type position that is beneficial overall to the market, they very often point to the swaps market and say swaps brokered generally produce higher levels of efficiency in the market. To have a look at what a swap might represent, if we took the previous case here, an agreement by a bank to pay 6-month LIBOR and receive a fixed rate of 5% per annum. The way that breaks down is if we had a 3-year swap where the payments are going to be exchanged every 6 months, where one rate is linked to LIBOR and the other rate is fixed at 5%, what we have then is we have a counterparty. We might think of a counterparty as on the one hand paying, may think of the position of the counterparty who's paying the 5% fixed, right, or receiving, in this case, receiving the 5% fixed. If we divide the 5% by 2, it's 2.5 every 6 months, or 5% a year. And the LIBOR rate that is paid in the swap is known in advance. Most interest rates that we receive on deposit accounts and so on, or we pay on loans, we know in advance. So if you like, there's kind of a lag here. The LIBOR rate that is payable is the current rate. So the 4.2, if the current LIBOR rate in time period 0 when the swap is negotiated, if the current LIBOR rate is 4.2, then at the 6-month interval we would expect that the counterparty paying LIBOR would pay half of that amount to 2.1. So that's knowable in advance. But the other rates here are not, and the last rate at year 3, it doesn't matter anyway because it's not going to influence any payment in the swap. So it's these rates here, at least known in advance, the current time frame. That 4.2 LIBOR that's reported today, that will determine the rate paid in LIBOR. So the party paying LIBOR will pay half of the 4.2, 6 months later 2.4, pay 2.65 and so on, and receive the 2.5 each period. And this won't change, it's constant. It's, after all, it's the fixed side of the swap. So the party who is receiving fixed paying LIBOR, right, receiving fixed paying LIBOR, will initially be gaining here with the LIBOR rates that are in vogue, and then subsequently the LIBOR rate goes up and exceeds the fixed wing of the swap, and then the party who's paying receiving the fixed rate starts to lose. Okay, so you can see that the swap payment, if this was negotiated on the principle of 100 million, the actual amount of money that changes hands is actually just the difference between two rates, and then ultimately some of the money that's gained may be offset subsequently by money lost, and so on. So the amount of money changing hands in swap contracts very often can be a very tiny percentage of the overall notional principal that the swap is negotiated on. So the notional principal here is the 100 million at stake. Okay, so that's a kind of a swap type setup and payments, and the main thing here is just to, I suppose, understand that the swap contract is not a one-off. It's a series of exchanges, and we might even view the swap as a kind of a series of forward rate agreements that follow each other in time, but where the fixed rate is negotiated and known in advance, and the LIBOR rate is the rate that's unknown. Let's take an example then of a swap type structure. This is one again that I've taken from John Hull. We have two companies, let's say, A and B have been offered the following rates on a 20 million 5-year loan, and A and B go to their respective banks and they're wanting to borrow money, and when A borrows funds, what they are offered in terms of the fixed rate, let's say, is 12%, and what they are offered in terms of borrowing is LIBOR plus 0.1% on the floating side. So company A has these rates available in terms of borrowing respectively in fixed and floating, and company B would appear here to have higher credit risk, and we would pay 13.4% on a loan that is fixed and would pay LIBOR plus 60 basis points. What we need to do here is to engineer a swap where we know in advance A wants a floating rate, B wants a fixed rate, and we've got to engineer the swap so that a financial intermediary would take 10 basis points per annum for negotiating a swap contract, and both of the counterparties A and B would mutually benefit by exchanging rates. Okay, so this is first of all, what we've got to observe is if we look at the rates quoted, what we can observe is that in the case of B, when they borrow fixed, they pay 1.4% over what A pays. When they borrow floating, they pay 50 basis points over what A pays. That would suggest some form of market inefficiency or some kind of market rigging. The spread between the two rates seems a little bit implausible almost, and that perhaps there's some kind of arbitrage type possibilities available here relative to these rates. And again, a number of authors, including Stultz 2004, would point to when they're looking for markets that provide opportunities or derivative markets that enhance market efficiency, they very often point to the swaps market, because they have the view that the swaps markets improve the level of transparency in terms of interest rates. Okay, so just read a little snippet of what Stultz provides here. A second important benefit from derivatives is that they can make the underlying markets more efficient. For example, derivative markets produce information. In a number of countries, the only reliable information about long-term interest rates is obtained from swaps, because the swaps market is more liquid and more active than bond markets. In addition, derivatives enable investors to trade on information that otherwise might be prohibitively expensive. For instance, short sales of stocks are often difficult to implement. In the context of this example here, there is a market inefficiency. B would appear to be penalized when they borrowed a fixed rate, and less so when they borrowed a floating rate. If we had a situation where A wants a floating rate, right? So if A wanted to borrow not the fixed rate, but a floating rate, they pay this LIBOR 0.1, and we would say A has an absolute advantage in both, but comparatively on the floating side, A has a disadvantage. And likewise for B, B has an absolute disadvantage in both, but comparatively speaking, A has B has a comparative advantage. Okay, so A has a comparative and absolute advantage here, borrowing at 12. B has a comparative advantage borrowing on the floating side, and perhaps we could use these relative advantages to engineer improved outcomes. Now, potentially, how much looking at the figures that we have here, how much do the counterparties to the deal here, to a swaps deal, how much could they potentially stand to gain from entering into a swap type arrangement? And the way we can determine this is we just take the difference between the spreads, and we can see that the 1.4, if we subtract away 0.5 from the 1.4, the 0.9 that represents the difference on the spreads is the potential savings available. And then if we say, okay, let's engineer a swap and let a financial intermediary design the swap, manage the credit risk and so on, we would perhaps want to reward them for taking on those risks. And if we made available 10 basis points or 0.1% to the financial intermediary or the bank for negotiating the swap between the counterparties A and B, right, the 0.1 that we would then deduct from 0.9 would leave potential savings of 0.8 to the two counterparties. And if that would then mean 0.4 for each counterparty.